Up until now, all of the programs we've been running have essentially been sets of deterministic, static instructions, lines of code that run the same no matter what. It turns out that this isn't really useful. Most of the time, we want to be able to make a program behave differently based on user input, based on different circumstances, based on whatever we want. That gets at the idea of conditional execution. We want to be able to use these Boolean true or false conditions to make a program do different things based on circumstances. So the structure we use for that, at its most basic form, is an if-else construct. The syntax is pretty straightforward. We say if some condition is true, this is where the Boolean condition goes in these parentheses, then do all the statements that are enclosed in the curly braces. Else, or otherwise, do all the stuff that's in these curly braces. Now, you don't have to have an else. You can have, as we do in this first example, just an if by itself. Likewise, you can have, as we saw on the last slide, an if and an else together. If you want, and if you only have a single statement that you're going to execute if that condition is true or if the condition is false, you can even leave off the curly braces like we have here. If this condition is true, we'll run statement 1, else we'll run statement 2. Now, this can get a little messy. Let's take a look at an example of a code snippet where things get a little hairy. Here we have a little chunk of code. What we want to do is take an integer and print it if that integer that we took is positive and even. So in this first line, we have a scanner object called reader calling the next int method and assigning whatever we get into the variable n. If n is greater than 0, then we want to go on here. Note there's no curly braces here, so we move on only to the next line of code. So if that's true, if n is greater than 0, then we check if n mod 2 equals 0. In other words, we check if n is even. If n is even as well, then we print system.out.println n, so we print n just by itself, the number. Else, we print n is not positive. So suppose we ran this and we input the number 7 as n. The print statement we're going to get back is going to be 7 is not positive. Now that's not what we expected, because we would think, okay, if n is greater than 0, well, it is greater than 0. Then check if n mod 2 is 0. Well, it's not, so we won't execute this, and neither would we execute the else. But actually, the way this is indented is misleading. Because we didn't use any curly braces, this else is dangling, and it ends up matched with the nearest unpaired if. So what we ended up doing with the input of 7, we checked if n was greater than 0, and it was. So then we went to the next line of code. When we checked if n mod 2 equals 0, well, it failed that condition. So then we skip the next line of code, and we end up at this else. So rather than having this else paired with the first if, as we might have intended, this else ends up paired with the inner if, which is not really what we meant to do, and that's why we get this nonsensical answer. That's why you have to be really, really careful with your curly braces when you're working with if and else constructs. If you do choose to drop the curly braces because you're only going to do one single statement inside the if-else construct, you can mix and match. So you can drop the curly braces on the else, but leave them in with the if. But again, you want to be really, really careful when you do that. General policy, it's better to overuse braces than to underuse them. Thinking about the condition, general idea is the condition has to be some Boolean expression. It's got to evaluate to either true or false, such that we could follow one of these two paths. Here on the left, we have an example of just an if statement. We enter, test the condition. If it's true, we run the statement. If it's false, we don't run any statements, and we come out the other end. Here is an example of an if and else construct, where we have a condition. If it's true, we run one set of statements. If it's false, we run another set of statements, and we end up all the way out. But the key is that we have to have a Boolean, a true or false condition. You can actually chain these conditionals too. So I can evaluate one condition and run a statement if it's true. If that's not true, I can evaluate another condition. If that's not true, I can evaluate a third condition. And if that's not true, I can go ahead and run this else block. Now this can go on indefinitely. And one really crucial thing to understand is, if this condition is true and we run this statement, we never even check any of these other conditions. We never even touch them because we skip straight to this statement and then out of the if-else construct. Let's take a look at some example code snippets. Here, we want to increase a saleswoman's commission by 10% if her sales are over $5,000. So we're checking if the sales are over $5,000, then we'll increase the commission by 10% by multiplying by 1.1. Okay, here you can see no curly braces, but there's only one statement, so there's no confusion. Here we want to pay a worker $14.50 per hour plus time and a half for any overtime that he or she works. So normal pay is hours worked times 14.5. And if hours worked is greater than 40, then we want to figure out how much overtime there is and add a bit more for that overtime. Third snippet of code, again, you'll see no curly braces, so we have to be very, very careful. We want to assign the larger of two variables, A and B, to a third variable, C. So we check if A is greater than B, then C equals A, otherwise C gets B. Now we used these relational operators there before. There's a couple other ones that we didn't see. First we have greater than or equal to, less than or equal to. We also have equal to and not equal to. Now, this is really important because a common mistake is using a single equal sign for equal to. If you're trying to compare two numbers, a lot of people accidentally use a single equal sign, but they're different. We call this single equal sign the assignment operator. That's what we use when we want to set the first thing equal to the second thing. When we want to compare whether two things are equal and get a true or false value as a result, we use the equality operator, this double equal sign. So let's take a look at a longer example here. This is called How Was Your Day? Let's get a quick overview of the code. Okay, we import scanner, we make a string called answer, and we are declaring and instantiating a scanner object called myReader. We'll ask the user how his or her day is going, prompt them, take a string, and store it in answer. If the user says yes, we want to tell him great. Otherwise, we want to wish him well. So here we've got our if-else construct. Again, no curly braces. Got to be careful. Oh my gosh. If answer dot equals yes, that means we're happy for them. We'll print, hey, I'm glad to hear that. Otherwise, if they typed in anything other than yes, then we want to wish them well, say, well, I hope it gets better. Now, oftentimes we're going to use an if-else construct to make sure that a user's input is actually valid. So let's go back to that program for a second, and we'll see that right now we're only really treating the situation where the user types yes. If they type in anything else, we're assuming it's no. That might not be right. So let's add a check to make sure that the user's input is exactly what we're looking for. Here's what I propose. If the user didn't answer yes or no, then we want to tell them that their answer was invalid. So if not answer.equals yes, and if not answer.equals no. That means if the user's answer wasn't yes, and if the user's answer wasn't no. It means if it was anything other than yes or no, then we want to print, hey, your answer wasn't valid. Otherwise, we enter this else block, and we do this second check. So this means we're entering here if the user's input was valid. We're going to check if answer equals yes, we'll print, hey, I'm glad to hear that. Otherwise, and remember, the only other way to get in here is if the user answered no. Well, that means the user's day was bad, and we'll say, I hope it gets better. Notice that we've got nested if-else constructs. We've got an if-else on the outside, and within the else block, we've got another if-else on the inside. So now open up the circle area program from the code files for this lecture. I've got it already loaded into Eclipse, so I'll just pop that open real quick. Let's take a look at this code for a second. Okay, I'm importing the scanner class. Looks like I'm calculating the area of a circle based on its radius. So scanner reader equals new scanner, fantastic. I'm prompting the user, enter the radius. I declare a double, and I get a double from the user. Now I'm checking if that radius is less than 0. In other words, if the user gave me a negative radius of a circle, which doesn't make sense, then I'll print an error message. Error, radius has to be greater than 0. Otherwise, I'll declare a new double. I'll multiply it by math.pi. We'll talk about this next time, but it's an easy way for me to access the value of pi. And I'll multiply pi times the radius to the second power. We'll see more about this math class in the next lecture video. The result of this calculation gets stored in area, and then I print that area out. So let's run it just to make sure it works. Okay, enter the radius. Let's say the radius is 7 units. Well, look, the area is 153.94. Okay, before we close up shop today, a couple things you want to make sure you can do. First, you want to make sure you can write an if-else construct with an if by itself, or with an if and an else, and with one or more than one statement in each part. You want to be able to use or omit curly braces from the if-else, and know when you can omit them when you have a single statement. Hopefully you remember how to use the equals method to test whether one string is equal to another. You should be able to take a look at the mathematical and logical operators we looked at before and use them to string together Boolean expressions and tell the difference between the assignment operator and the equality operator. That's it for today. Take a look at the exercises in the distribution code.